I would try foiling it first. Now, sure, it's the same rules. But it's just like the exponents may be a little weird, but let's just follow the rules. This times this, if I FOIL it's the first thing. So h of x is going to equal 7x to the negative 1/2 plus, that's the first. The outer is negative x to the negative 1/2 times x to the minus 1. This thing times this thing. So minus with these two things multiplied next to each other. This times this is 14x. And then these two things is minus 2x times x to the negative 1. Does that make sense, you guys? How are we feeling with that? I haven't multiplied them together yet. I just want to see that I just FOILed these two things. Or if you set up your area model, either way to multiply every term together. Okay? How are we feeling with this, Michelle? So now we can just do our exponent rules. h of x equals, this is 7x to the negative 1/2 plus, okay, two things, same base. What do you do with the exponents when you're multiplying these two things together?
Add.
You add the exponents. So what's negative 1/2 minus 1? Yeah, how I write it, I'll take away the 1 because I can't add fractions without a common denominator and write 2/2. So in this, now I can see that negative 1/2 minus 2/2 is, yeah, or with, yeah, negative 3/2. Okay, so it's still a minus there, x to the negative 3/2. How are we feeling with that, Lehman? Okay, plus 14x, I'm just leaving it as it is. Okay, now x, and if you don't see it, it's a 1. So x to the 1 times x to the negative 1. Same basis, what do you do with the exponents? You add them. What's 1 plus a negative 1?
0.
What's x to the 0?
1.
It's gone. Okay? So now we can do the problem from here, which may be easier. Okay? Does that make sense, Jesse? So look for that if it helps clean it up. Okay? Maybe it will, maybe not. If you don't want to do it, I don't care. You can do it either way. In either case, you just need to create a function that'll find the rate of change. You need to take the derivative. So as long as you're following the rules, you're all good. Well, in this case, if you did that, this is all power rule in each case. So what's this one going to be? What's the derivative of 7x to the negative 1/2? Keep it as improper fractions too. You don't have to do the 3 and 1/2. You know what I'm saying? Or 3.5. This becomes, it's 7 over 1 times negative 1/2 is what? Yeah, negative 7/2 x to the negative 1/2 minus 1, or minus 2/2 is minus 3/2 plus, what's this one going to be? What's the derivative of negative x to the negative 3/2? 3/2 x to negative 5/2, yeah. Plus, what's the derivative of 14x? 14, what's the derivative of negative 2?
0.
And there's your derivative function. Do you know what I'm saying? You choose which way you want to do it. As long as you know the rule, you're all good. If you wanted to create the derivative, okay? This one is going to be a hot mess too. Well, it's going to be pretty messy. But I'm going to try foiling it first. Square root of x is the same as what exponent, Allie? Yeah. So I'm just going to rewrite these like that. And I'm just going to multiply these out to begin with. F of x equals x to the 1/2 times x to the 1/2 minus x to the 1/2 plus x to the 1/2 minus 1. Multiply the first two things together, the outer, the inner, and the last. Well, let's use our exponent rules. X to the 1/2 times x to the 1/2. Same base. What do we do with the exponents? Add them together. What's 1/2 plus 1/2? It's 2/2, which is 1. What's minus x to the 1/2 plus x to the 1/2? 0. There's your function. What's the derivative of that? 1. Okay? This is a big nasty way to write the function x minus 1. Now this one, the only difference, Amina, the only difference Amina, is that this function doesn't have the same domain as this function. What's the difference? Yeah, between the domain of this function and the domain of this function.
You can't have negatives.
You can't have negatives. So then this can't. This function, the derivative, it can't exist for negative values. Does that make sense, you guys? If it doesn't exist in the regular function, even though like when you clean it up, it's fine. This is still the original function. Okay. So that's the only difference. But if you just when you take the derivative of it, this is your derivative function. But it still only exists when x is greater or equal to 0. Okay. Do you guys see that, Rafi? Does that make sense? Okay. All right. So let's have some fun with fractions. We like fractions. Right or no? How do I solve this lovely problem? I want to know what 7/5 minus 3/5 is. How are you doing this so mathematically? What are you guys doing? Denominators are the same. What do you do with the numerator? Sure, this is the same as 7 minus 3 over 5. Do you agree with that, Chris? Okay. So, would you also agree then, and if you have something like this, that you can go back to this? So, if you have some denominator and you have two things subtracted, you can rewrite this as this. Would you agree with that? Again, same. I'm just subtracting two things in the numerator so I can split them up if I so choose. Same like I did here. 7/5 minus 3/5 is the same as 7 minus 3 over 5. Yes? Okay? Well then, from here, okay, square root of x is x to the 1/2. Now, what's that rule when you have two same bases and you're dividing? You subtract their exponents. So what does this become? 3x to the what? Yeah, this is 2 2's. 1 is the same as 2 2's, so 1/2 minus 2/2 is negative 1/2. Minus, what's this the same as? 2 over x is the same as what? Yeah. Okay? Again, which way is easier? It's all the same. Our goal is just to take the derivative. But here's some ways I like, any chance you can do power rule, it's just going to be easier to take the derivative. Okay, Jesus? Okay? So what is the derivative of this? Bring this number down and multiply 3 over 1 times negative 1/2 x. Bring this one down, and then this becomes negative 1/2 minus 2 2's is negative 3 2's. And now, what's this derivative going to be? 2x and negative 2. Does that make sense, guys? Yeah? Okay. So let me ask you this. Let's go with so whenever we do, we talk about something like this, like breaking up the fraction, then we deal with something like this, Eves, okay? Now, this is the same as 7 over 7 plus 7 over 1, right? You break it up, right? So we can do, what? Yeah, this is Cookie Town rules I'm doing here, right? This is 7/8, right? A number less than 1. This is, look at this, this is 1 plus 7. This is the number 8. These definitely are not equal. Does that make sense? My shoes are not brown. Do you know what I'm saying? They are brown. So what I'm saying is this is not the same as x over x squared plus x over 1. Not the same. Just be careful when you do some of the breaking up. You know what I'm saying? It's like, oh yeah, Mr. Remus, the Mr. R special. You broke it up and whatever. Well, be careful. You can break up your numerators because that's the numerator rule. But with denominators, you're stuck with that big chunk of a denominator. Okay? Does that make sense? Okay? All right. So what do we got? A minute? Yes, perfect. Perfect time.